Quadratics, solving them using the quadratic formula. All right, we've done a lot with quadratics thus far. We've talked about solving them using factoring. We've talked about solving them by completing the square. We've talked about solving them using square roots. So now we're going to get into the quadratic formula, which, as you might imagine, works for all quadratics. Nothing's particular about this. We have two objectives in this lecture. Number one, we're going to solve quadratic equations using the quadratic formula. And number two, we're going to determine the number and types of solutions of a quadratic equation using what's called the discriminant. So we'll define that a little later on. All right, so what do we know? Okay, we know, and we've been going over this a few times now, we know that what a quadratic equation is. It's an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a is not equal to 0. Again, a is the coefficient of the x squared term. You must have an x squared term in order for it to be a quadratic. And so if a is 0, you won't have an x squared term and it won't be a quadratic. So a cannot be equal to 0. The quadratic formula is as follows. When you're given the standard form of a quadratic equation, which we know again is ax squared plus bx plus c equals 0, the solutions to the quadratic, what x equals, can be found by using the following formula. X is equal to the opposite of b plus or minus the square root of the quantity b squared minus 4 times a times c, all of that divided by 2 times a. So that's your quadratic formula. There are some different ways to remember it. One of them is a song, but I won't sing it for you. But there's the formula. Now, again, as I mentioned earlier, we know that factoring only works if the quadratic equation is factorable. The square root method only works if b is equal to 0, if there's no x term. Completing the square always works, but you have to first make sure the coefficient of the x squared term is 1. The quadratic formula doesn't have any restrictions. It works for everything. Okay, it doesn't matter what a, b, and c are. You just write them down, substitute, and simplify. Okay, let's take a look at an example. All right, so we're going to solve the quadratic. 3x squared minus 5x plus 1 equals 0 using the quadratic formula. All right, it's already in standard form, so we're good. Okay, so I'm going to write it down. Let's see here. So 3x squared minus 5x plus 1 equals 0. And I'm going to note the coefficient of the x squared term is a, so a is equal to positive 3. The coefficient of the x term is negative 5, so b is equal to negative 5. And the constant is positive 1, so c is equal to positive 1. I'm just writing the positives here just to differentiate clearly from the fact that b is negative 5, because I don't want to lose my negative. So I just differentiate it by doing that. Okay, so the formula says x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2a. So let us substitute. Again, I'm not going to do any math yet. I'm simply going to replace the letters with parentheses, and then I'm going to put inside the parentheses what the letters represent or equal. So the opposite of b is negative 5. This is probably the one place that catches students the most. This is the opposite of b, so you have to make sure it's the opposite of whatever b is. Okay, so in this case, b is negative, so it's the opposite of negative 5. Notice I didn't do any math. I just replaced the b with parentheses, and then I put negative 5 inside the parentheses. Okay, plus or minus, square root, parentheses, negative 5 squared, b is negative 5, minus 4, open parentheses, times a is 3, times c is 1, all that divided by 2 times a, and a is 3. Okay, here's where I get up my calculator. I feel pretty good about the denominator, that's 6. All right, and I feel pretty good that the opposite of negative 5 is positive 5, and the answer is plus or minus. Well, what is under this radical? I'm going to take out my calculator and do the portion under the radical separately. So the opposite of negative 5 squared minus 4 times 3 times 1, and I come up with 13. Okay, I come up with 13. Now, this tells you, before I go there, so our solution set, we have 2 answers. And in quadratics, you almost always have 2 answers. So our solution set, is, and I'll write it with curly brackets, well, we have 5 plus the square root of 13 divided by 6. That's the addition, add the square root, and we've seen that in previous videos. And we have 5 minus the square root of 13 divided by 6. Okay, so that's my solution set. Now, these are the exact solutions. If you were to put this into a calculator, you're going to wind up with an approximation because the square root of 13 is an irrational number. There's no way to have this come out as, there's no exact answer as a decimal. The exact answer is when you use the square root of 13. So these are the 2 exact answers, which is why I did not immediately put this in my calculator, because I would have gotten an approximation. I went ahead and solved what's underneath the radical, and then I wrote this down as the exact answer here. Okay? So it's important to note, working to get the exact answer. Okay, so now let's talk about the discriminant. Move my paper up a little bit. Okay, so the quantity b squared minus 4 times a times c. So the quantity, let me move this down just a touch. So here's the quadratic formula. The quantity that's underneath the radical, the b squared minus 4ac, has a name, and it's called the discriminant. If I can spell it correctly. A-N-T, discriminant. I think that's right. It's called the discriminant. Okay? So the discriminant is what is underneath the radical sign. And as you might imagine, okay, if what's underneath the radical sign is positive, like positive 13 here, you get 2 answers. 5 plus the radical divided by 6, 5 minus the radical divided by 6. If what's underneath here is 0, well, then you're going to say 5 plus or minus 0. Well, 5 plus 0 and 5 minus 0 are the same thing, so you're only going to wind up with 1 solution to the quadratic. And if what's underneath the radical is negative, we got a problem, because there's no such thing in the real number system as the square root of a negative. Okay? So let's jot that down. If the discriminant b squared minus 4ac is greater than 0, just like in our example, it's 13, which is greater than 0, you have 2 real solutions. And that's what our example showed us. Here's one real solution, here's a second real solution, both of which the calculator can approximate for you. Okay, if the discriminant, b squared minus 4ac, is equal to 0, you have one real solution because you're plussing or minusing 0. So your answer in this case, if this were 0, your answer would be 5/6. Okay, it's only one solution. If the discriminant, b squared minus 4ac, is less than 0, well, we know they're not real solutions because there's no such thing as the square root of a negative number. So what I'll speak to is, because we're going to see this in upcoming video lectures, you have two non-real, also called imaginary. Some of you may already be familiar with this, solutions. Because there's no such thing in the real number system of the square root of a negative number. Okay, let's take a look at a couple of examples of what the discriminant tells us. So example 2, how many solutions of what type does the quadratic, and I'll abbreviate quadratic equation, I'll abbreviate those two words, quad equation, 3x squared plus 2 equals 4x have. All right. Well, okay, how many solutions does this have? Well, first off, we need to rewrite this in standard form. So I'm going to subtract 4x from both sides so that I have it equal to 0. Equal to 0 is in standard form. So I'm going to rewrite, it's going to be 3x squared minus 4x plus 2 is equal to 0. This is, whoops, I'm not going to write that. This is in standard form. And I'll note that the coefficient of the x squared term is positive 3. The coefficient of the x term is negative 4, so b is negative 4, and the constant is positive 2. Okay, how many solutions? Well, I use the discriminant to find the number of solutions. So I'm going to take b squared minus 4ac is equal to, well, b, I'll use parentheses. B, of course, is negative 4. Negative 4 squared minus 4 times a is 3, times c is 2. And I'm going to pull out my calculator because why not? So negative 4 squared minus 4 times 3 times 2, and I came up with negative 8. So the value of the discriminant is negative 8. Well, if the discriminant is less than 0, the discriminant is negative, I have two non-real imaginary solutions. How many solutions? I have two. Of what type? They are non-real, or also called IMAG, imaginary. Two non-real or imaginary solutions. Okay, let's do one more example. The discriminant. Make sure I can see my paper here. This will be example, trying to get it straightened out for y'all. Example 3, same question. How many solutions of what type does the quadratic equation 9t squared minus 6t plus 1 equals 0 have? Okay, so it's nice. In this case, it's already in standard form, so I'm pretty good to find my A, my B, and my C. I'm going to rewrite it. I'm going to note the A is equal to positive 9, the coefficient of the squared term. The b is equal to -6, the coefficient of the linear term. And the c in this case is the constant, which is +1. My discriminant is b squared minus 4ac. Okay, so let's see here. b, parentheses, so I don't lose negatives. -6 minus 4 times a is 9, c is 1. I can do this one mentally. -6 squared is 36. 4 times 9 times 1 is 36. 36 minus 36 is 0. So my discriminant is equal to 0, which means I have one real solution, one real number solution. So there you have it. I'll look at quadratic equations, the quadratic formula, and the discriminant.